Hey guys! So today this lecture video is over 6.1 and 6.2 together. We're going to talk about graphing certain trig functions. So I've got a graph set up for us here, and we are going to start by graphing sine x. So the equation we're graphing in its most basic form would be y equals sine x. So when we were learning about sine and cosine, a lot of times we use theta here or a different variable, but you guys, x is the angle that we're putting in. We're using x and y, so it easily relates to our graph. Now, when you think about graphs of trig functions, a lot of times the graph that comes to mind is the unit circle. And I want to get us out of that thinking because it can really make us confused. The unit circle is just the graph of a circle. Sure, that circle has a lot of valuable information, like the points on the circle that help us learn the sine and cosine of different angles, but it's not the graph of those trig functions. It's just a circle that contains values of those trig functions. So we're going to kind of stop the circular thinking, and we're going to talk about graphing y equals sine x. So just remember, x is your input. When you're taking the sine of something, the input of the function is the angle. So the sine of 30, for example. Y is the output. So the sine of 30 is 1/2. So the input is 30 degrees and the output is 1/2. Now, the problem with degrees is, even small angles like 30 degrees, do I really want to count out to 30 before I even start? Especially when, think about the sine of 30 degrees being 1/2, the difference between those two values, you would have 30, units out this way, and then you'd only go up to 1/2, and you'd get a really skewed looking graph. So when we graph sine, cosine, well, all of them, we actually use radian measure for the angles. So you'll notice that on my x-axis here, I have it separated into units of radians. Notice I've got pi over 2, pi, 3 pi over 2, and 2 pi. You guys think about the angles that we know, the ones on one full rotation, going from 0 to 360 or 0 to 2 pi. This will cover one full rotation of angles, and we'll talk about what happens after one full rotation. But you guys, I do have it separated. Notice each of these units between these values I've got is pi over 2. So I've got our graph separated into units of pi over 2 radians. All right, so let's get started. Putting in an angle, getting out a value. So you guys, what is the sine? And I'm going to start at 0. So you guys, this is a good place to start when you don't know what a function looks like. Well, what does it equal at 0? So remember, 0 on the x, that means 0 is the angle you put in. So the sine of 0. Remember that 0 degrees and 0 radians are both the same. It's all 0. So when we're at 0, what is the sine there? While we're not thinking circular when we graph, if you have your unit circle beside you for reference while I do this, that would be really good so you know where the numbers I'm getting are coming from. So if you are looking at a unit circle, go to the angle 0. Remember on the unit circle how sine is y and cosine is x? Go to the angle 0 on the circle, find the y value. You guys, it should be 0. So the sine of 0 is 0. What does that mean? Remember, you put in x and you get out y. So we have a point at x equals 0, y equals 0. All right, so let's go to this next unit I have here. So I want to put in pi over 2 as my x value. So I put the sine of pi over 2. Remember, on your unit circle, this is straight up. It's 90 degrees. So I'm looking on my unit circle at 90 degrees or at pi over 2. What is the y value there? It should be 1. And it is. So you guys, the sine of pi over 2 equals 1. Here's x is always the angle, so x is pi over 2. y is 1. So on the y-axis, because the y-axis doesn't really have pi's in it, the values we get for these trig functions are like 1 and 0 and 1/2. The y-axis is just going to be in normal numbers. So I'm just going to make a 1. So here's y equals 1. So x is pi over 2, y is 1, and we get a point there. Let's move on to pi. Let me make some room. Okay, so we're moving on to pi. What is the sign of pi? You guys, 180 degrees on your unit circle, it's the one out to the left. You guys, the y value there is 0 again. So the sign of 0 is 0, but the sign of pi is also 0. So when I put in x equals pi, I get out y equals 0, and we're back here. All right, let's go to 3 pi over 2. You guys, 3 pi over 2 is 270 degrees. So straight down on your unit circle, what's the y value there? The y value there is -1. So that's a new one. I need to mark it on my y-axis. Remember, I put in 3 pi over 2 is x. My y value is down here at -1. All right, so we have one more point I want to look at. 2 pi. Let's find the sign of 2 pi. Okay, so we're back around. So remember that, I don't have 0 up here anymore, but the angle 0 and the angle 2 pi end at the same place. They're coterminal. We've just gone a whole rotation now. So 360 or 2 pi, looking at that spot on the unit circle, your y value there, or your sign, is back to 0. So at 2 pi, we're back at 0. Let me erase these. Alright, so I've got a bunch of points, but if you don't know anything about the sine function already, this might not be enough. You guys, how do these points connect? Do you think they might connect in straight lines like a jaggedy zigzag situation? Or, or what, right? So you guys, sine and cosine functions take the form of waves. So when you see these points here, think about connecting them with a smooth wave. And you guys, this is what you get, and this is the shape of the sine function. So it is a wave. I'm sure you've heard the term sine waves before, and this is why, because sine is a wave. So you guys, this is y equals sine x. Now, here's the thing about waves. They don't actually stop at a certain point. This one starts at 0 and stops at 2 pi because I chose that. So I chose to start it at 0 and to stop at 2 pi. I just wanted to show you one full rotation. But what if I went around again? So I went all the way around, I got back to 2 pi, and then I started rotating again. If you rotate another rotation, you could be at 4 pi and do it again and be at 6 pi. Remember how the angles work. They just keep spinning, right? Even though the rotation's getting bigger, all those sides, so all those angles are really going to be coterminal. They're going to be hitting the exact same spots over and over. So what do you think is happening here? Well, we started here, we went up, we went down, we came back to where we started. Once we get back to where we started, it would just continue doing the same thing. It would go up and down and up and down. And you guys, over here, even though we started at 0, the sine wave technically goes to all those negative values too. So from here, it keeps going. When you're doing your ALEKS work and they ask you to graph one of these functions, you are going to use specific points to help graph it, but you're going to notice that your graph just keeps going, and you're going to graph it, and it helps you graph it in a way that this wave just keeps going on forever. But the ones that I draw, usually because of lack of space, we usually just go one full rotation. But do know this is going on in both directions forever. Speaking of stop and start points, one full rotation of sine, so from 0 to 2 pi, is what it takes to get every point on the sine function covered, and then it starts over. So we call this section, how long does it take to complete one full cycle of the sine function? We call that the period of the function. So what's the period? Well, how long does it take to do one full iteration of this wave and then before it starts over? It takes 2 pi units, you guys. So the period of sine is 2 pi. That basically just means every 2 pi radians, it's going to repeat itself. It's just repeating in these increments of 2 pi. Okay. So this is the basics of sine. What I really want you to get out of this, because you're going to have to graph sine quite a bit, is I want you to be able to do it fast. I don't want you to have to make a table of values every time or really even have to reference your unit circle at a point. I want you to remember these 5 important points. Think about where it hits the x-axis and where it hits its high and low. And then that should be enough, right? So you guys, for sine, I like to say it hits the x-axis, or it has x-intercepts at the pi's. And I know that's a little bit informal, but what do I mean by the pi's? I mean, well, you can think about this as 0 pi, 1 pi, 2 pi. If I kept going, we would hit it again at 3 pi, and 4 pi, and 5 pi. So you guys, intercepts at the pi's. That gives me these 3 points. Where's it hit highs and lows? Well, just remember, high and lows, they always happen at the pi over 2's. Here's pi over 2, here's 3 pi over 2. If I kept going, the next time it hit a high, it would be at 5 pi over 2 and 7 pi over 2. So, intercepts at the pi's, highs and lows at the pi over 2's, remembering that the first one is high. What else do we need to know about this? Where are the highs and lows? You guys, the high is at 1, the low is at -1. You guys, the sine wave stays within this little section. You guys, we call that the range, right? The range of a function is what y values it covers. What values could the sine possibly take on? And you guys, the range of the sine function, as you can see from this graph, and if you're looking at your unit circle and you look at all those values, they all stay within -1 and +1. That is the range of the sine function. Now I'm using interval notation here. So if you don't recall, while it looks kind of like an ordered pair, it's really an interval. You put the left endpoint here, or the smaller end here, and the larger end on this side. So we go left to right. And the brackets mean that it includes this value here. So when I say we have a range from -1 to 1 and it's in brackets, it means it's a closed interval, which means my range does include -1 and it also includes 1. It does take on those values and any values in between. All right, so we've got our range, we've got the period of 2 pi, how long does it take to get one iteration done? And remember, intercepts at the pi's, highs and lows at the pi over 2's. The more you remember these 5 points, the easier and faster it gets to graph y equals sine x. Now, I am going to leave this basic y equals sine x graph up, but I'm going to change it a little bit in the equation. Because we've all seen waves that are much larger than this graph. Maybe they're really tall, or maybe they're really short. Maybe they're really fast, you guys. Maybe the frequency of the wave is really fast. How does that happen? You guys, it all stems from the sine or cosine wave. So here's y equals sine x. I'm going to introduce a value into this equation. So notice it's almost the same, except for there's an A in the front. You guys, sometimes our equations look like this. It looks like the basic version with an added number here. So if you have a number, notice it's multiplied. It's like a coefficient on sine. Right in front, this is what we call the amplitude of the wave. It determines how high your high point is and how low your low point is. So the amplitude, think about the basic version. I'm going to add a number in here because technically it's there. When we just have y equals sine x, we do have an a value. It's just 1. So if I'm saying that 1 for this equation determines how high my high and my low are, I think it would make sense. Notice from this middle, what we call the midline, the x-axis, the highest I go is 1, and then the lowest I go is -1. So I went up 1 and down 1, and that's as much as my amplitude would let me go. But what if I changed that? So this A here being amplitude. What if my equation was y equals 2 sine x? How would that change this graph? All it would do, all that's different is this A or this amplitude value here. Let's note that that means the amplitude of my new function is 2. And what I would do is notice it does not change anything about your x-intercepts. Those stay the same. The only thing amplitude affects is your highs and your lows. So an amplitude of 2 means that our high point here, I'm going to have to erase that. Our high point's usually here at 1. Yeah, when the amplitude's 1, but our amplitude is 2 now, so our high point's going to be up at 2. And your low point that used to happen here, it was at -1 at its lowest. Now it's going to go down to -2. None of the other points change, only the highs and lows. So let's look at our new graph. And if it was continuing, it would look something like that. So you guys, can you see how amplitude changes things? I like to think about the middle being held in place somehow, and you're just taking and you're stretching up and down at the same time. So here's an amplitude of 2. Let's look at a different amplitude. So that was y equals 2 sine x. What if I want to, instead of stretch it, what if I want to compress it? What if I want to push it together? I can do that with a fraction. So what if I want to graph y equals 1/2 sine x? Well, my amplitude is just 1/2 now. It means that my high point can't go up to 1, it can only go up to 1/2, and my low point can only go down to -1/2. So the high point now is here, and the low point is here at -1/2. But everything else is the same. Nothing else is changing except for those highs and lows. And that's what we get, you guys. So this is y equals 1/2 times sine x. All right, so amplitude is a pretty easy change. A is pretty easy to pick out. I mean, yeah, it's just the number right here. Okay, so there's one thing that sometimes makes it a little difficult, and I want to show you that. I wish I had another color, but I don't, so we'll just have to work with that. I want to graph y equals negative sine x. So this one's different. I had a negative yet. Now, this could be negative and have a number. It could be -2 or -1/2 or negative anything. The point here I want to talk about is the negative. Sorry. You could look at this and notice, what is your A value? It's there. It's -1. You could say the amplitude is, you want to say the amplitude is -1, but does that make sense? As my amplitude gets larger, like 1, 2, 3, 4, 5 and on, I'm stretching. And as it gets smaller, like the 1/2, I'm compressing it. But at a point, it would reach 0 and it would just be a straight line, right? So it doesn't make sense that amplitude, which is, it's like a distance. You guys, amplitude is the distance from the high to the midpoint, or from the low to the midpoint. It's not going to be negative. So you guys, when you pull out the amplitude, I want you to think about it in absolute value. You say, sure, there's a negative there, but it is not affecting my actual amplitude. It's going to do something else, and I'm going to talk about what it does. But anytime there's a negative, it will not be included in your amplitude. So always bring out the positive number for your amplitude. And the amplitude of this graph that I'm about to do is 1. So it's going to have a high of 1 and a low of -1, just like the purple one I already have. So what's that negative doing? That's the question. This negative is going to cause a reflection. I'm going to have to reflect this graph. Every time we reflect a sine or a cosine function, when we see this negative in front, we reflect over the x-axis. I want you to think about it as an up and down reflection, because what it means is that we're still going to start at 0. Our x-intercepts are still going to be at the pi's. Nothing is changing about that. Notice on this one, our amplitude is still going to be 1, so it's still going to go up as high and down as low. So how does it change? We reflect it across the x-axis. What was up here is now down here, and vice versa. So we start at 0, but instead of going up to 1, we go down to -1. We still hit the intercepts at the same place. I'm going to have to erase a little bit of that. But instead of going down here, this is now our high point, and we go back down. So look at the purple line, our normal amplitude of 1, not reflected, just your basic sine function. And look at your reflection of that basic sine function. This is all that negative does. The only thing a negative ever does is flips it over the x-axis. So I want to note that this amplitude and this reflection, any way you want to have an amplitude or a negative in front, what's not changing? Well, the x-intercepts never changed. We changed the amplitude, they stayed the same. We reflected, they stayed the same. And I want you to remember that. We will be moving those, but not with amplitude and not with a reflection. I'm sorry. All right, so next, I am going to erase because we're getting a little crazy here. But I'm going to draw another blank graph, and we are going to look at cosine. We're going to talk about the amplitude changes with cosine, and we're going to talk about reflections that happen with cosine and how to deal with them. And then that will conclude this particular video. And in the next video this week, I will continue. We're just going to keep talking about graphs, changing them, transforming them, but this is where this one will end. So everything I just did with sine, I'm going to now do with cosine, starting with graphing it. So remember, I'm going to get my x-axis set out in those units of pi over 2. You can think about these as quadrants if you want to, since our angles are rotation based. you can think about what is 0 to pi over 2 or 0 to 90. This is the first quadrant, the second, the third, the fourth. When you're looking for values off of your unit circle, that's where you're going to find them. Remember, we are talking about cosine now. So this is going to be y equals cosine x. All right, so on our y-axis, I'm going to go ahead and put in the 1 and the negative 1 because I happen to know those are going to be high and low points for cosine just like they are for sine. We're going to hit them at different places. So remember, when you're looking at your unit circle for these values, cosine is the x value of those coordinates. So keeping that in mind, what is the cosine of 0? So go to your unit circle. It's that first value before you've moved it all. We're at 0. What is the x value there? It's 1, right? So the cosine of 0, you put in 0 for x, you get out a 1 for your y. So we're already hitting our high point, and we haven't even moved off the y-axis yet. So that is different, right? Let's find the cosine of pi over 2. Remember, pi over 2 is straight up at 90 degrees. What is the x-coordinate at that angle? You guys, the x-coordinate there is 0. So at pi over 2, our value for y is 0. I need more space. All right, so what is the cosine of our next spot? The cosine of pi. So we're back to the left at 180. What's the x value there? You guys, that is -1. So at pi, when I put in a pi for x and I'm looking for cosine, I get -1 on the y. Let's go to 3 pi over 2. You guys, what's the cosine of 3 pi over 2? Check out your unit circle. What's the x value straight down at 270 or 3 pi over 2? Well, your x value there is 0. So we're back to 0. And you guys, once we go back around to the 2 pi and you're looking for the cosine of 2 pi, remember, it's going to be the same as 0 because it's coterminal. It's just gone a whole rotation, and we're back to that cosine of 1. So let me get this lined up. So it looks different, right? But you guys, this is still a wave, so I know it's going to be connected with those smooth lines just like sine was. And you guys, sine and cosine waves actually take the exact same shape, they just happen at a different time. So basically, sine and cosine are the same wave, just shifted from each other. And you guys, again, these do go on forever. And if I kept going, it would go down and back up again over here, and it would do the same thing here. It would be going down and back up again. But notice, just like sine, it takes a whole rotation. It takes a whole 2 pi radians to do one full iteration of the wave before it starts again. You guys, I like to think about cosine as a trough or a valley. That's usually the words that come to mind when I think about the cosine function, because it starts high, it goes low, see the valley there, and then it ends high. All right, so like I said, it takes 2 pi to do an iteration of cosine, so the period is 2 pi, just like sine was. What do you think the range is? Remember, the range is high and low. How much of the y-axis does this function take? Well, the range is just the same as sine. It happens at different places, but it still hits -1 and hits +1 and doesn't go outside of those values. And you guys, remember, an amplitude change obviously would change that because it would be stretching or condensing. But when I talk about this range and this period, it's for this basic function. So just cosine x or just sine x. Of course, those transformations you do with amplitude and stuff are going to change things, but this is for the basic version. Okay, so if this is basic cosine, why don't we change it up a little? Let's make sure we know how to change the amplitude of a cosine function like we did with sine. I'm sure we do, but I'm going to do it with you anyway. So let me erase all my extra business here. All right, so we are here. Oh, before we do that, I forgot to, like I did with sine, I want you to remember your 5 important points for cosine. I think for cosine, it's more about remembering that it's like a valley or a trough, but where are the x-intercepts on cosine? Remember for sine, the x-intercepts were at the pi's. Notice now, for cosine, the x-intercepts are at the pi over 2's. So that's where it's hitting the x-axis. Where are the other 3 points? They're the highs and lows. Where do they occur? They occur at the pi's. So they are exactly opposite of each other. If you can remember that sine has x-intercepts at the pi's, you can also remember cosine is opposite of that. It has intercepts at the pi over 2's. If you can remember that sine has highs and lows at the pi over 2's, you can remember that cosine has highs and lows at the pi's. So they're just opposite of each other. But anyway, so let's move it around. Let's find y equals 1/2 cosine x. What am I changing? How does this change from the original version? There's a 1/2 there. It's the only thing that's different. What is that value called? Oh yeah, it's called the amplitude. The amplitude is 1/2. It means that instead of going up to 1 and down to -1, we're only going to go up to 1/2 and down to -1/2. So, I'm going to erase that thing that I just wrote. Remember, what does this change? Only the highs and lows, not the intercepts. But look, our first is a high. You guys, the first point you come to is the high point up at 1. So you take it down to 1/2. This intercept is going to stay the same. Your low point isn't going to go down to -1 anymore. It's only going to go down to 1/2. This intercept is going to be the same. And your high point's not going to go back up to 1. It's going to stay here at 1/2. So, same exact shape, it's just dampened. You guys, when I talk about amplitude, think about a sound wave and why we use amplitude for sound. This is fun because the higher the amplitude of the wave, you guys, the more vibrations, the more air it's moving, right? So the sound gets louder. It's literally seeing the amplitude here in a picture. So here's the 1/2. Let's do another amplitude. I'm going to do a little combo. We've changed the amplitude and we've reflected, but not at the same time. So I want to do y equals -2 cosine x. So the first thing I want to put into my mind is labeling what's changing. When you have more than one thing changing, you have to be able to keep it straight. So the first thing I notice, there's a negative. What does that mean? It means I am going to take my normal cosine function and I'm going to reflect it. How do I reflect it? Across the x-axis. It's up and down reflection. What is this 2 telling me? Well, it's telling me the amplitude is 2. Remember, amplitude never gets to take that negative with it. Amplitude is always a positive number because it is a literal distance between a high and low point. Okay, so I need to do these 2 things. You guys, I like to start with the reflection because I know where my point needs to be on which side of the axis, and then I'll use the amplitude to see exactly how low or how high it needs to be. So your first point, remember, let's work off the purple one because that was our normal basic function. Your first point is a high point. It's at 1. If I'm reflecting across the x-axis, remember this high point for my reflection would be a low point. So I say, okay, it's not going to be up here at 1, it's going to be down here. But is it going to be at -1? No, our amplitude is also changed. Our amplitude is 2, so it's not only going to be down at -1, it's going to be down further at -2. So you guys, this is your very first point. I made 2 changes to find that point. My next point is an x-intercept. Do you think that's going to change at all? No, you guys, these changes here do not affect the x-intercept. So just graph that same intercept. Now, look at your next point here. It used to be a low point, but remember, we're reflected. So now it's going to be a high point, and it's not just going to stop at 1, right? Your amplitude's 2, so it has to go up to 2. So I got to erase this. I'm sure you guys have that written. So you guys, not only did we reflect this to be a high point, but we put it up at 2 because of that amplitude change. So what's next? Intercept again. Stays the same. We only have one more point to change. You guys, it used to be a high point. Again, we're reflected. Now it's going to be down here. Where down here? Down at -2 because of the amplitude. So you guys, it's not really too hard to do these 2 steps at once. If you need to take it 1 step at a time, maybe you do the reflect and then you stretch it. Or maybe you stretch it and then reflect it. It really doesn't matter which way you go. But you can take more steps if you need to. I think that amplitude and reflection work really well together. So what happened to this wave? Well, first of all, I flipped it upside down. It's not a trough anymore. It's a mountain or a hill. And it's taller. It goes higher and lower because of the amplitude. So amplitude changed to 2 and -2. Reflection changed the orientation. Instead of going down like this, it went up like this. So you guys, that's where I'm going to stop with this video, and I'll be putting the other one up probably tomorrow. It would have been very long if I did it all in the one. So this will get you started, and then we'll talk about some things. Remember, we haven't changed the x-intercepts at all. Amplitude doesn't change it. Reflections don't change it. We're going to find out how to change those next time.